Could you tell me about your background?
Yes, my background is in infrared spectroscopy. I worked for over 28 years at Procter & Gamble in that field and retired 5 years ago and started my own consulting company. And for the last 3 years, I've been a scientific advisor for Anasys Instruments. And they're a company that developed out of the atomic force microscopy industry, a bunch of scientists who started a new company, and they developed a product about 3 years ago that was introduced at Pittcon that combined infrared spectroscopy with atomic force microscopy. And at that point, they started bringing me on as a scientific advisor to help with the spectroscopic aspects of the technique. And so basically what they've been able to do is pretty revolutionary in terms of spatial resolution of IR. Typical FTIR microscopes that you can buy from many companies can do spectroscopic characterizations in the infrared, but only down to about 5 to 10 micron spatial resolution, because the diffraction limit of the radiation used limits the spatial resolution. Anasys has figured out a way to get around that by actually using the tip of an atomic force microscope as a detector. So they're able to use a tunable laser source going through the sample that excites the tip and causes it to oscillate only when the sample absorbs at that wavelength. And since the tip has a much smaller geometry, they can beat the diffraction limit of the spatial resolution by about 2 orders of magnitude and do spatially resolved IR spectroscopy down to about 100 nanometers or less. So what that does is open up all kinds of new samples that are amenable to study by IR that you couldn't do before, and it enables you to get chemical information in addition to the topography information that you get from IR alone. And what they've been trying to do is become more than just an AFM imaging company. They're trying to be a nanoscale characterization company, so they've added techniques that can provide more information. The infrared is one example. Their first product was actually a nanothermal probe where they were able to heat up the AFM tip and measure thermal properties as a function of temperature very quickly at 100 nanometer spatial resolution. And then this past year they've added nanomechanical characterization where they actually perturb the sample at different frequencies and look at the mechanical responses. So the net result is they have a technique that can potentially get inside of a material and see interactions at spatial scales that no one's been able to look at and chemically characterize before. So that's sort of the idea behind what they do.
Great. And what are the next steps for the company? What's in the pipeline?
Well, we can't talk about everything, but there are definitely new things coming along that will make the technique more useful to a wider variety of samples, adding new types of capabilities besides just infrared, adding ways to get more chemical information at nanoscale resolution. So there'll be more and more things coming out in the coming months and years.